like a streaming setup to me. If you ask me, it's like more of a warm white sort of a thing.
Not really. Okay, go for it.
Okay, cool. So just let me pull up the activities tab again. I'll keep monitoring the Q&A. Yeah, so there are no questions right now. Okay, we have a lot of people joining. We already have 20 people. That's nice. Okay, cool guys. We'll start. So welcome to RVC Models 101. I'm Tanay. I'm one of the co-hosts, and the star of today's webinar is not me but Dr. Sharath, who has a cooler streaming setup than me. So today, the overall agenda is that we'll try to decode what these RVC models are, how do they work, and then try to develop an intuitive understanding on when they fail. So I'm assuming a lot of you are already have all of these fancy badges in your respective Discords that say you are a model master, you create models for commission, so on and so forth. But there might be a lot of places wherein what happens is when you're putting in the audio, there are some places where the model kind of fails, it's not up to the quality and all. So what we thought, I and Dr. Sharath thought was that why not kind of deconstruct it right in front of the public and let them decide on, okay, yeah, if this is breaking, why is this breaking? If this has to be changed, what has to be changed here? Okay, so let's quickly start. We are already 4.5 minutes in. I'll quickly start. So yeah, this is RVC Models 101. Welcome again from wherever you're joining in. I and Dr. Sharath are based out of India, and it's almost 10:30 p.m. here, so way past our bedtime. You might hear a lot of fancy noise coming from my end because it's apparently the wedding season in India, and we usually celebrate it with some sort of moving bands, if I may, and a lot of firecrackers. So there might be occasional sounds. Don't think there's a shooting or anything going on. Everything is cool. Okay. So moving forward, this is basically a Dubverse Black initiative. Dubverse Black is nothing but the open source wing of Dubverse. I'm one of the founding team members at Dubverse, and Dr. Sharath is one of our very close friends. And whenever we have any issues, we just run to him because again he has a degree and he has, I think, more citations than all of us combined, maybe even 4 or 5 times, anyways. So we write a lot of blogs. You can find them on black.dubverse.ai. We do have a Discord, not very active, I'd say, but whenever there are certain technicality things, because we actually, on that note, I'm personally doing a deep dive into these Gemini use cases, wherein what I'm trying to do is I'll kind of release a blog and supporting material there as well. So if you want like a first step here, you can definitely join our Discord. Of course, you can join our Discord for RVC related discussions, which is why we are kind of doing this. Oh, I actually see that there's a user called AI Songs who joined in. Very interesting to see the technology adoption. Okay, so let's dive right in. Oh, okay. So before I start, I'll kind of set the framework for this call for this webinar. What we'll be doing is for the first 10-15 minutes, we'll be talking about what is RVC and how it works. For the next 10 to 15 minutes, we'll be talking about some of the hacks, some of the problems, some of the best practices. How do you take it forward? And the last 10-15 minutes, we are kind of taking it for Q&A. So if you have any questions that you want to ask, there is an activity. Disclaimer: no one here is allowed to send messages directly in the chat. What you need to do to raise a question is click on the activities tab, which is right next to the messages tab, and then click on Q&A and then ask a question. There will be a lot of other people who would have already asked their questions. So yeah, we can move forward now. Okay. So again, I don't think I need to kind of introduce what is RVC, because if you guys didn't know that, none of you would be in any of the servers wherever we kind of pull that we will be doing a webinar. So if I look at RVC, it's nothing but it has an input audio. You take that input audio, you pass it through an RVC model, and the speaker is changed. So when we look at it, there are 3 simple observations. The first is that it is a speech-to-speech system, wherein the input is a speech and the output is a speech. That's observation number 1. The second one is that the speaking style is preserved. Let's say I say something like, shit, why did you do this? And if this audio is given input to the RVC model that maybe behaves like Kanye West or Steve Jobs for that matter, it will say in the same intonation, shit, why did you do this? Not something like Alexa or Assistant or Siri, wherein they are more, how do I put it, conversational or assistant type in nature. That's observation number 2. And the third observation, the most interesting observation that I think would be the center stage of the entire webinar, is that the model is trained only on the speaker voice. So let's say if I'm training a model on Steve Jobs' voice or Kanye West's voice, I just need their audio data. That's it. Nothing more, nothing less. So I'm not giving it any labels. I'm not giving it any transcripts. Nothing. So basically, net to net, what the case that I'm trying to make here is RVC is nothing but an audio replacement pipeline. It's just a, if I may, glorified version of Talking Tom, wherein you used to say something and then you used to say something. That's it. The same way you said it, but maybe in a different pitch. Here, instead of changing the pitch, we are changing the speaker identity. So let's go. If I look at a simple example, one of the very famous quotes by Steve Jobs from that Stanford commencement, if any one of you guys is into it, it's "Stay hungry, stay foolish," which kind of should be everyone's life motto. But again, we are not here for that today. If I take that "Stay hungry, stay foolish" in Steve Jobs' voice and pass it through an RVC model, I'll get the same way Steve Jobs said "Stay hungry, stay foolish" in Kanye West's voice. So let's try to deconstruct what might be happening here, right? What might be happening is, because we are saying it's an audio replacement pipeline, what it might be doing is it might be taking "stay hungry, stay foolish" and dividing that into chunks. Something like "stay hungry, stay foolish," right? So it has some sort of chunks wherein you are able to see, okay, how this worked out. Then what it might be doing is it might be trying to map it to the chunks of Kanye West's voice. So how would Kanye say "sir"? How would Kanye West say "ter"? How would Kanye West say "I," "her," so on and so forth? Then what it might be doing is, oh, of course, this is that retrieval part wherein we are retrieving what sound looks like this in the trainer's voice. So that's that retrieval part here. Then what it might be doing is it might be pulling all the pieces together, and then you get that thing again in Kanye West's voice. So again, stay hungry, stay foolish. What we're saying is, broadly what it's doing is it's dividing that into certain audio chunks, taking those audio chunks, trying to find a match or trying to retrieve the closest match of that specific sound from that trained model, pulling it up, putting it all together, and then giving you that output. That's pretty much RVC for you. And I think that's it. I hope everyone enjoyed it. And of course, no, I'm just kidding. We have a technical deep dive coming in. So brace up. Of course, for all the people who are joining in right now, we just closed one small thing here, wherein we are saying that how RVC is working on a very high level, wherein if an example is "Stay hungry, stay foolish" in Steve Jobs' voice, and we are passing it through an Kanye West RVC model, what's happening is it's dividing that into audio chunks. It's retrieving the closest audio segment related to that and pushing it all together and giving you back the output. That's literally it. Nothing more, nothing less. So again, I'll be repeating this again and again, because if literally nothing you learn from this webinar, if you can just remember this is how it works, you'll still be able to debug, or you'll still be able to come across as a good model developer, maybe more than the 99% of the model developers out there. So yeah, again, back to technical deep dive, and I'll let this pass to Dr. Sharat now.
Tanak, can you allow me to share screen? I think I don't have the permissions. I'll probably share screen and do this myself. And you're on mute, I guess.
I'll run it for you. I'm not sure what's happening here.
Sure. So I don't have permission. All right, cool. Can we go to the next slide?
I just gave you the permission, so you'll be able to change the slide numbers here. Can you see that on your screen?
Oh, I can. Awesome. Oh, this is cool.
Perfect.
Cool. All right. So you've seen this slide. Okay, start with it. Hey, I'm sure. So I've been working with audio, building machine learning models applied to audio analysis and synthesis for a long time now. So I probably kind of understand this a little bit in a holistic manner, so which I'm trying to see if I can convey the same here. Let's start with the same slide that Tanay has been showing so far, right? What is really happening, right? If you run RVC by yourself on your machine, it downloads a bunch of models. If you observed it, probably the two key models that is interesting for RVC is the one which is Hubert Bayes, which basically takes audio input and generates some kind of a phonetic embedding. Yeah, I mean, it need not be, when I say phonetic, wait, I'll come back to it, right? So it takes an audio and gives you some kind of a breakup like this. And then there is the next model, which is, okay, and then in this case, you don't need to train this model. So it's a pre-trained model that you download, and then you just use it as it is. And then there's this FAS. It's basically a search system that helps you quickly retrieve what is the nearest phoneme in a different speaker. For now, just go with me. Probably in a couple of slides, we'll have more details of this, which will probably uh, give you the full context. And then there's a third part, which is the other model, which you will end up training, which is the pre-trained underscore V2, which is downloaded as well, right? So these two models, the Hubert base and the pre-trained V2, are the ones that are downloaded. Fires is just a library that we use, right? So when you're training RVC model, the first step that you do, you're actually training this pre-trained underscore V2, right? You're just fine-tuning it with respect to your data. That's basically what is happening. We'll get into the details of each of these in the coming slides. So the first model, right, the Hubert-based model, what it does, or rather, it is a fairly popular model in the sense that there's a very detailed explanation of how this model works, how it was trained, and all that in this link that is in the bottom. So in case you need more information beyond what I'm talking about today, just go to this and have a look at it. At a high level, it takes audio as an input. It works on audio, which is 16 kilohertz in sampling rate. So it's trained only for this. It doesn't work with higher sampling rate. So if you're using higher sampling rate, you probably need to downsample it. If you're probably using the RVC software, it's internally it's already downloading your high resolution audio, high sampling rate audio to this 16 kilohertz low sample audio. This is still good enough for voice samples, but if you're generating singing and with some instruments, if you're extending this to non-speech content, then probably you'll need to retrain it with higher sampling rate. So for now, it works on audio 16 kilohertz, and it generates. I mean, I wouldn't call it phoneme, but probably the nearest. It generates some kind of unique units within speech, which represents unique sounds, right? So the nearest. I mean, in the paper, they keep referring to it as units, a vocal or audio unit. But for simplicity, for now, in this presentation, I'll call it as phoneme. Generally, what it means is, like, for instance, if you think of English, when you read or write it, you're using only 26 characters, right? But when you think of every letter, depending on the context, you can pronounce it in different ways. In that sense, English roughly has about 44 unique ways of unique phonemes, right? So, for instance, the letter C, depending on where you use it, can be, if it's in cat, it is C is pronounced as cat, but if it comes with an H, it becomes chat, right? So CH is chat, but it's the same letter C, right? So depending on the context, the same letter is spoken in different ways, and these different phoneme, unique sounds that we make, the C as or C H as ch is what I call as phoneme, right? So what this model does in general is, given an audio of certain length, it goes through the entire audio and gives you roughly what are the sequence of phonemes, and it doesn't tell you that this is the phoneme, but it just gives you a vector. That is why I'm calling it as an embedding. So let's for the sake of example assume that a 10-second audio had about 100 phonemes, which means it generated about 100 vectors, right? So embeddings are generally vectors. So depending on what model you choose, probably in this, they have two versions of it. One of the versions had 256 dimensional embedding, right? So which means 100 phoneme sequence would have 100 cross 256, right? So that's the matrix that you get out. And just to kind of think about it, right? So this particular model, the one which at least is shared in the repo of RVC, it's not explicitly called out as to what it is trained on, but since they're using the term Hubert underscore base, Hubert base is known as the English model, right? So in the sense, it's trained on this publicly available data called Libre speech, which is mainly read speech, right? When I say read speech, it is basically open source data of audiobooks, which has been curated and it has multiple speakers in it. And that's the kind of data it is trained on. And it is trained on in a self-supervised manner, right? So in the sense that when they trained this Hubert model, they didn't use the text part of it. They just used the audio. And they just use the audio. And then from the audio, they're trying to learn these unique embeddings, right? So there's a loss function called masked language models or masked, and that's the kind of objective function that they're using to train this model. I'll probably stop at this. I don't know if I have to go super deep here, but in case you want to go deeper, you can get into this paper. In short, all you need to understand here is, given an audio sequence, this model generates a phoneme embedding sequence, where every phoneme roughly represents the letter or the character that person is speaking in the audio, right? So that is all you need to know here. We can go to the next model, which is this is the model that you end up training here, right? So for instance, in the example that we were using here, where we see that the red color, right? So we want to go from Steve Jobs' voice to Kanye West's voice, which means I'll probably end up collecting Kanye West's voice and then start training the model. But when I say I'm training the RVC model, I'm really training this pre-train underscore V2 model, which is what you would end up downloading. So again, if you want to understand what is this model, it is actually a version of this model called WITS. It is a conditional variational autoencoder with adversarial learning. So you can imagine, so it has again a generator and a discriminator. If you want to again double click and then go into the details of how this was trained and all that, probably needs a much longer session. And if you want more details, click on the link in the bottom. It's available for you to read. Again, here what this model is doing is it takes as input the phoneme embedding sequence that we generated in the previous model and generates back the audio, right? So here, so what you're doing here is not really training this model from scratch. When you're saying you're training RVC model, you're actually fine-tuning the model, which means this RVC model has already been pre-trained on some data. Unfortunately, at least to the best of my knowledge, I couldn't find where or what kind of data was used to train this model, right? But I saw some notes online that mentioned that, hey, this was probably trained on some multi-speaker English data, right? So ideally, the more diverse the data is, and when I say diverse in terms of the number of speakers, in terms of the genders in it, in terms of the voice diversity, right? So my voice is quite bassy. I'm sure there's some people's voices were like a little bit shrill and high pitched. So you have that kind of a variety of voices. And if you have like in terms of this expression as well, right? People who can really talk in a super expressive manner, right? So like voice actors, or even like how you would hear actors talk in a movie and all that, right? So if you have audio recordings of that expression, then this model can actually be used in those use cases as well, right? Where the model can generate expressive voices as well. But in this case, again, from our experiment, it feels like the default model that we download when we use the RVC model seems to be only trained on English and not really on expressive data. So we are roughly thinking it's probably one of the same data that the Hubert model was trained on, but probably might be wrong, right? So there's no clear information anywhere. And one other thing that you would have probably seen is one of the options to choose to train your RVC model would be a pitch extractor, right? So what it means is, again, it may or may not help for the data that you're using. But in addition to the phoneme sequence that you got from Hubert, which was the previous model, you can also input the pitch of the audio, which is taken to kind of give a cue as, because the same phoneme, right, can be spoken in different ways. What I mean is, like, for instance, if I say, I'm just taking an example from the title of the slide, right? Trained for target speaker, right? So you see that the phoneme, I don't know, trained for target speaker. I can probably say trained for target speaker, right? So I pushed, so my pitch was quite high for the first trained word, and then it went down. So I can use that pitch with the same, where the underlying phone or character was exactly the same. It was the word, the letter T, but the first I kind of stressed a lot, and the next I didn't. So that stress information is something that we can introduce via pitch, right? So that is the motivation of using pitch there. It may not help you a lot if you're using RVC for generating content which is kind of monotonous, it doesn't have too much voice modulation. But if there is a lot of voice modulation, that's where probably this pitch will help. But again, even if you use pitch, if the data that you're using to fine-tune your RVC model does not contain sufficient voice modulation, then it's not going to help you, right? So the ideal recipe is your data that you're using to train actually has voice modulation, and in addition to that, you're using pitch as one of the input features, right? So that's when this all it turns out to be a good voice cloning. With that, I'll quickly move on. So just now, those two models that we just referred to, right, the Hubert and RVC model, how does it work now, right? So I know what it means, what does it do, but how do we put it together? So going back to the same example that Tanay was talking about, we have the Steve Jobs voice, which says "Stay hungry and stay foolish," and I wanted to want the exact same audio to be converted into Kanye's voice with the same text, right? So how do we do that? What we do, I think there's something that you guys have been playing around with, where you generally take a bunch of audio of a certain user. In this case, let's say Kanye's voice. So you take the voice audio of the audio of the voice that you want to generate, right? So in this case, since I want to generate Kanye's voice, I take recordings of Kanye's and then I use that to train my RVC model. As the first step I do here is I would take the Kanye audio that you have. Again, the bunch of things that you do in terms of pre-processing, which we'll probably cover in a later step, but assume that you have Kanye's audio, which is in a certain segment. You've already broken it down into like 5 seconds, 10-second clips. You take the audio, you run it past the Hubert model. As I mentioned earlier, Hubert model gives you some kind of a phoneme embeddings. So as long as whatever you're speaking in your audio, some representation of that in phoneme space is what it generates. And that phoneme embeddings is what is used to train the Kanye RVC model. How it is trained is simply you give the phoneme sequence, the phoneme embeddings that you've generated from Hubert model, and then you use the same audio that you used as an input to Hubert model to train the RVC model, right? So you are basically saying, hey, here's the phoneme embeddings of Kanye, here is the audio of Kanye, just figure out a mapping between this phoneme to audio. Right? As you see here, the Hubert model, you're not training it, you're just using an out-of-the-box model. Whereas the RVC model is something that you are training yourself on the data that you've collected. Right? So that is the thing there. Now, how do you inference it, right? So when you're trying to copy Steve Jobs' audio to Kanye's audio, what are you doing here? You're basically passing the same audio in the exact same Hubert model that we use for pre-processing during our training. It generates embeddings. There's some information of Steve's voice also in this, right? So that's why I'm calling it Steve's phoneme embeddings, which will not be identical to Kanye's phoneme embeddings, right? But it's still they probably have the same character. They're probably talking about the same phoneme or same character, but it may not be an exact identical copy of Kanye, right? In that scenario, given that I've trained my Kanye RVC model only on Kanye's embedding, I cannot give Steve's embedding to it to generate audio, right? I need to somehow go from Steve's embeddings to Kanye's embeddings, and that is where we use this FIAS, which is the Facebook AI Similarity Search. Again, an open source library which anyone can use. I mean, it is basically an embedding search algorithm. What it means is, how do you say? So when you probably the simplest analogy is when you go to Google and ask a question like, hey, where's the football World Cup going to be this year, right? It gives you an answer. What is happening in the background, right? The query is going to a search system and it retrieves the right answer and gives it back to you. So that search and retrieval is what it is doing, but instead of doing it on text documents, this is doing it in an embedding space where the embedding in this point is the phonemes that we have generated here. Right? So it is just a search algorithm. It has two key components. One is indexing and one is query. When I say indexing, it is basically saving all the unique phonemes in your training data in some kind of a library. And querying is you're trying to retrieve the nearest phoneme for Steve's voice, right? So pictorially, if you want to see it, it's something like this. So what you do is during the training, for every unique phoneme that you see in the training, right? So whatever is coming out of the Hubert model, you see the Kanye phoneme embeddings. You take all those embeddings, you index them, as in you put them in a some kind of a dictionary where you have all the embeddings of Kanye's, and that dictionary right now is made inside files. And now during inference, what happens is you push the Steve Jobs embeddings that you have, and let's say, for instance, just for the sake of example, right? So you have, let's say, the phoneme of Steve coming in, and then you're trying to find out what is the corresponding phoneme of Kanye, right? So that is the kind of search you're doing for every unique phoneme in Steve's phoneme sequence, right? For, let's say, the audio that's coming in, again, the same example, 10 seconds audio goes in, you have, let's say, 100 characters in the 10 seconds. For each of these characters or phonemes, you're seeing what is the corresponding Kanye's phonemes. Because Kanye's phonemes is what I need to infer or to use the Kanye RVC model. All right, so that this FIAS is just helping you with that. Given 100 sequence of characters from Steve Jobs, it'll give you 100 sequence of Kanye's embeddings for the same. And these embeddings are what goes into your Kanye RVC model, which ends up generating the audio. All right, so this is basically what is happening there. Yeah, basically that's it. I'll probably go through some of the questions you have here before I pass it back to Tanay. How do
summary of what we done? Actually, I think if I believe that we covered a lot of technical details in a very short span of time.
Got
so
it.
But let's go back and then just summarize it for one thing.
Got it. So right. So if I take off like at a high level summary, right? So there are two key models. Okay, let me go back. Right. So
yeah, I think this is a good slide. Yeah.
There are two key models, right? Hubert and pre-trained. Pre-trained is a variational autoencoder with it's basically a GAN model. Now, what you're training when you're seeing RVC model is the pre-trained _V2 model. In fact, you're not just training; you're just fine-tuning it. There is already a trained model, which is probably trained on multiple speakers, and you're simply fine-tuning it on your data, on your voice data. The Hubert model is something that you don't train at all. You're simply using it out of the box. And right now it is English only model. So probably if you want to use it for another language, you probably want to train that with the language that you would want. And how to do that, it's probably straightforward. There's enough number of examples, training recipes available online. So if you simply look it up, you'll find it. You can simply train it. Probably finding the right data in your language might be the key. But yeah, so Hubert-based pre-trained model and then search. These are the three key components here. When you're training, you're simply passing the audio that you've collected without any text for it, right? You just have raw audio recordings of the person you want to clone. You use that audio, you do some pre-processing to get the phoneme embeddings of it via the Hubert model. You train the Kanye RVC model using the embeddings and the audio. Right now, that's the VAT model. If you want to go back to the paper and quickly read it up. And then if you want, during the inference part, you are basically passing whichever voice, right? It can be Steve's voice or anyone here, right? If you just speak, your voice or your audio recording is passed through the same Hubert model. We get a phoneme embeddings. This phoneme embeddings is associated with your unique voice. It's not Kanye's embeddings, it's your embedding. So it might not be identical to Kanye's embedding. So we need to go from Steve's embedding to Kanye's embedding, and that's where we use FIAS algorithm. It's just a search algorithm where we have already indexed all the Kanye's phonemes that we've seen in the training data, right? These are the phonemes that are part of the training data that the audio recordings that you've collected, and you're simply mapping the phonemes from Steve's sequence to Kanye's sequence. And this, once you get the Kanye's embeddings, which are corresponding to the phonemes of Steve embeddings, that is the thing that I have in that light red right of the FIAS, light red color right of the FIAS block. That is good enough to generate the Kanye audio output, right? So that is what is happening. Cool, that's it. Do you could we take the question towards the end, or there's like few more slides?
I think there are very relevant questions right now.
This point. All right. Okay. So starting with Gwen's question, right? So it says how to resource and train data for another language without English. So Gwen, there are two things. I'll probably I'm just thinking. So okay, let's wait for a couple of more slides. I think by the time we go to the Brad ideas, I think we'll have.
Yeah.
So you most of these questions, I think you'll find answers to very quickly. Wait. So wait for a couple of more slides. Wait up. Tanay, you want to pick it up? No?
Okay, sure. Thank you so much, Dr. Sharath. So I'll reiterate what he said, but maybe I'll try to use a bit more simpler English.
Right? Yeah, probably go for it.
Yeah. Again, I'll go back to the slide and I'll tell you what we're doing. And because I think that's what matters, right? Again, I'm repeating this again and again. If you don't remember anything from this session, and if you just remember what this slide was, I think that will make all the difference. Not even this one. Yeah, this one. That's it. What it's doing is whenever you're training the model of Kanye West, all that matters here, because we've been through the training process again, is how well the phonemes are mapped. Phonemes are nothing but a representation of sound. That's all you need to remember. When I say ka, ka, these are different phonemes, right? Different pitches. So if you're trying to run an inference on if your training data set does not have ka, and when Steve Jobs says stay hungry, stay foolish, there is 100% chance that your Kanye West model will fail, or maybe give you some sort of hissing or any other sound. That's what we're trying to kind of double down here. So again, at a very, very high view, you're taking that input voice, you're breaking it down, you're trying to find what's the closest voice that is matched in the trained model, and then you get that thing joined, and then that's what you get. Okay. So I think enough of engineering. I mean, enough of research. I think now it's time that we go to applied. Sorry, this one. Yeah. So now it's time that we go to applied RVC. Applied RVC is nothing but how, again, we've learned all of these things, right? Now let's start to think about how we can start solving problems whenever these occur during that RVC pipeline. So when we start thinking about data sets, the first thing that we need to think about the data set is that there should be no background noise. If there are background noises, again, the phonemes would be a bit off, and then search would go off, and then everything goes down the gutter, right? Pronunciation should be clear. So if you're listening to me, you might know that I have just a bit of a lisp, right? Wherein wherever there's like extra air that comes out of my mouth, which kind of messes up certain pronunciations. Pronunciations being one of those words, of course. So your speakers should have clear pronunciations, and if not, then again, that speaker matching, that retrieval part will go messed up, and then your RVC models won't perform well. If I go back here, this is an interesting piece wherein we are always talking about phonemes. What we also need to make sure is that your data set is phonetically balanced. What I mean when I say phonetically balanced is it should kind of cover all sorts of sounds there are. So usually a good rule of thumb is you don't need to kind of go and find phonemes, or you don't need to work on some sort of a code or a business logic wherein that looks at a data set and then says if it contains all phonemes or not. The general rule of thumb is, because these are kind of normally distributed, if you take a big enough data set, it's likely that you will cover almost 85-95% of all of the phonemes that exist. So there might only be certain places wherever your model is getting missed. And I think because you now know how these models are trained and inferred, you won't be able to pick it up. Okay, if it's kind of missing on certain places where the input audio is whispering, you might know, oh, because whispering was not in that original training data set, the output speaker cannot also use some sort of a speaking style that is whispering or shouting or crying or anything. I think there was a similar question here as well. Okay, moving on. Emotions. You need to definitely have emotions, because again, as Sharath was talking about, the difference in that harvest methods, the pitch extraction methods, comes from those emotions. Wherein if I'm speaking the same thing in a screaming voice, I might pick up some other phonetics. If I'm saying it in a normal voice like I'm doing right now, it might pick up something else. So emotive speech is very necessary. Phonetically balanced, or another way to say is a diverse or a big enough data set is necessary. Clear pronunciations are necessary, and you need to make sure that there are no background noises. Right? For background noises, there are a lot of these models, UVR models. Even I hacked one together. It's on the GitHub repository. You can check that out. The next one is style of speech. One interesting thing that comes here is accents, right? Again, I'm not trying to make fun of anyone here, but if you look at something like a British English versus an Australian English, British English is more like, hey mate, can I get some bottle, or can I get a bottle of water? Versus an Australian accent, that's very, very thick, or maybe an Indian accent wherein I'm speaking the way I'm speaking. So mate and mate, right? Same TECE, there are two different things. So you have to make sure whenever you're training your models, the audio that you're trying to infer on has the same accent as the model that is trained, or again, you know that these things can get messed up. What about languages? So again, I mean, I'm only speaking for myself, or maybe a handful of other Indians that are in this call, when I say that India is a land of languages. Europe is also, I think, but here there's a saying that says in every 20 miles, water is changed, and in every 40 miles, the language is changed, wherein everyone has their own certain pronunciations, everyone has their own dialects and other things. So what happens with these language or dialect changes, you kind of change the phonetic balance. So even if a person that's maybe from a British script, from Britain, speaks a certain script, you pass that, you train his model, and versus the same script that a person is reading from maybe an Australian accent, you train the same model. If you're trying to infer on a random audio, you will 100% get random results, because again, the languages kind of comprise all of the phonemes, or as Dr. Sharad is saying, some sort of an audio representation. So that's the dataset part, right? Now we are at model hacking, wherein I'll again give it back to Dr. Sharath, and I think that this is where a lot of your questions will get answered.
Correct.
Yeah.
Yeah. So probably most of the questions you were asking will get solved, but exactly what resources we need to figure out. So some of the ideas, right? So just thoughts here, right? So some of the problems that we see is sometimes there are mispronunciations, right? Even though you're trying to copy the voice within the same language, right? You're going from English to English. It is still possible that you don't get the pronunciation right. I think that's what basically Tanay was stressing on, saying, hey, and that where does it fit in is in the FIRES library I was talking about, right? So you ideally in a scenario where in your training data you have all the phonemes let's say covered, you will have a one-to-one mapping between, let's say, Steve's phonemes to Kanye's phonemes. But what happens when, let's say, you're training with a small data or a data that is not fully phonetically balanced is probably for some of the phonemes. So you see this, right? So some of the phonemes like the, re and all. So you don't have any corresponding phoneme in the training data, right? Imagine the red color that you have here is the training data right now. Unfortunately, you have a limited data. You don't have, and that limited data doesn't have these phonemes, the corresponding phonemes of the, ru, and u. Right. So then there's no way I can generate that sound for your voice unless it is part of your training data. Right. So that's the challenge. That's why it probably ends up mispronouncing, and that's where it's good to have some. Even if you're using the short audio data to train your model, having some kind of phonetical balanced data helps. That can be one of the issues. So one solution is, yes, phonetically balanced data. Another one probably, I mean, it's not a solution, but in addition to, when you use FIRES, in addition to telling, hey, this is the corresponding phoneme in red for the black phoneme, whatever you see in the screen right now, it also gives you a score. So based on the score, you can also roughly say, hey, as it gives you a score of how similar these phonemes are with each other. And if you see that there's a mismatch in the score, you can already say that, hey, your training data is not good enough, and you can probably use that as a cue to train your model or collect better data. All right, so that's one. Probably this is something that you would have also heard when you're using the base RVC model to train voices in a different language, right? So like I mentioned, your base models are trained for English, and especially the Hubert model that you use is trained in English, which means it probably knows only the unique phonemes that are in English. So in the scenario that you are, like for instance, someone I remember in the Q&A was asking for French and Taiwanese and all that, right? So these languages have unique phonemes that are not part of English, right? So that's when, again, it goes back to this, right? So in the black phonemes sequence, you'll probably have a lot more phonemes, but you will not have the in this case, sorry for confusing, right? So it is possible that the phones that are in English may not be the same as the phones in French, so they're going to be different. And because your Hubert model or the WITS model, the pre-trained model that we're using, is not trained on English, so it's not trained on the language that you want, the French or whatever you want to train on, it doesn't understand some of these phonemes, right? Or it might confuse the phoneme that it has never seen before to something else. And that confusion is what leads to mispronunciation, right? So the only way, I mean, again, I wouldn't say that there's going to be a lot of mismatch. For most languages, 70 to 80% of the phonemes are somewhat, I would say, relatable. You will find some close match, but there's always going to be this outlier, 10 to 20% of phonemes that are going to be unique to that particular language. Or even the pronunciation of those phonemes will be kind of very unique to that language. So those are the ones which will face issues with. Right. So the only way a solution there is to kind of train your Hubert model and the WITS model in multiple languages. For Hubert, I think, like I was mentioning, for any of the different language, all the questions that people have asked here, right? So for instance, the Sindol and Gwen, who is asking about how do I do it for another language. I saw one more person. Wait. I saw someone, yeah, Drago was asking for Taiwanese voice. Right. So all you guys, that's the problem, right? So you basically need to come up with a model that has seen your languages. An ideal scenario, both Hubert and Wits needs to have seen the language that you want to support. There's already for Hubert, there's enough number of open source models available that work out of the box or multilingual, right? So for instance, you can use simply the Whisper v2 embeddings, or you can use the Wave to Wake multilingual, what's it called, XLSR, right? So those embeddings as well, right? So those, they're like these models already are trained on multiple languages, unlike Hubert, which is in this case trained on just one English language, which will allow you to probably allow your model to understand phonemes better, phonemes across languages better. But the WITS model is probably something that might, well, I haven't found anything open source that is out of the box works fine, works well. I'll probably, if I do find something that is easy to use, I'll probably put it in Discord that Tana is managing right now. But for now, I've not found anything that works out of the box. You'll probably have to go figure out the training part of it. Like I was saying, the WITS model, the training code, everything is available online, right? So especially if you want to train from scratch. So if you go to this paper here, which is the, where was it? Yeah, this one, right? The pre-train underscore V2 slide. If you go to this paper in archive, they have the GitHub repo there as well, right? So you can look at the GitHub repo and see how they're training the model. You'll probably have to replace it with your data and your language, but I've not seen an implementation. Probably not so looked enough. Probably there is one, but at this point, I'm not aware of it. So, but the recipe is there. So as long as you have the data, again, because you don't really need labeled data here, right? You just need audio recording. So I think you should still be able to train that. So going back, so that probably answers most of the multilingual questions that were there. There is no shortcut here, right? So that's the only way we can make it work for multilingual at this point, which is your model having seen at least some amount of the language, the source and the target language. And going back to, I think there's one more, yeah, so right. So there's something that I think Dubverse also released, but this is probably for Indian languages at the moment. But also you can use it for any other language, right? So what if you want the cloning to happen, but not instead of the audio input the way it is in RVC, if you want to like use a text input, that's probably where you would want to replace the first model that you had, right? The Hubert model, which would go from audio to phoneme embeddings. Can I replace it with the text to phoneme kind of embedding model? But what we need to be a little bit careful here is the phoneme embedding that that this new model would generate should ideally be what do you say, identical or very similar to the kind of phoneme embeddings that Hubert generates, right? So one, you can probably play around with this Mahat ATS model, but you can also explore some other models. But this is possible, right? So we can quickly train the RVC, the WIT model or the pre-trained underscore V2 model on the voice of the speaker that you want, and use, instead of Hubert, use a text to phoneme kind of a model to simply make it a TTS voice for our cloning. That's something that, again, I wouldn't say that out of the box will be like amazing and you can start putting into production. There's some work around that's required here, but as a thought, as a idea, it is a feasible idea, right? So that is something which is interesting. And wait, was that okay? I think this is back to your section. But before that, right? Let me see if there's any question.
Let's just make some questions. Yeah. I'll also done a time check. We only have 14 more minutes left.
Achha, all right, so cool. So this is probably, this is something I don't know. Probably you can take the first question. I'm not sure what this .index file is, if you're aware.
Okay, so I like to think that the anonymous guy is a paid person from Dubverse. I'm not sure if Sharat planted them or me, but good questions is all I'd say, because like, these are anonymous. I cannot comment who did that, but good questions. That's actually, it does work well without index file as well. And you're right, it's related to the search feature ratio. I don't have an exact answer to this because I understand it from a very, very high level, because even when I was inferencing, there were a lot of times wherein I used to give the wrong path and then that used to work out. So what I'll do is I'll note it down and then maybe put it into Discord, or maybe with the slides, I'll answer this in a better way.
Yeah, I think for the next one, the Varshil's question, yes, noise plays a key part, Varshil. I think noise can kill this model, as any of the audio models. So I think one of the existing pre-processing pipeline already kind of has some kind of a noise removal built in. Not the best. That is something that they used to have work That's something that can be employed for rap and whispering. I don't see why it wouldn't work. It should work as long as both your as long as your the second model, right, the pre-trained underscore V2 model has seen these kind
Synchronous.
of yeah, right.
Seen,
So
seen these
exactly,
kind
if both of these models have seen rap and whispering before, I think it should work out of the box. But at this point, because it's trained on just audiobooks, not in a very expressive manner, I don't think it'll out of the box work for it. But it can be trained to work for these two easily. I don't think. I mean, there's no. It's just a data problem and not a modeling problem. Uh, how
Okay.
much data do I need to train the model? Hey, so that again, uh, I think the default answer that you would probably see in the GitHub repo of RVC is anything between 10 minutes to 20 minutes. But again, it's a function of what language you're training in, and then what accent you're using, right? So, for instance, if the RVC base model right now is trained on American English, right? And if your English, like let's say for me, my accent is probably heavily Indianized, and probably others, right? So, if that accent is completely different from like the US English accent, probably it may not sound great. But I mean, so if the accent difference is too much, you'll probably need a little bit more data. If it is not, if it's very similar, if it is probably like American voice itself, then you probably need 5 to 10 minutes of data, and it should work out of the box. Right? RVC shows Roman Fink. RVC shows. Wait, where is this? RVC shows me a G path and a D path. What is the yeah, so Roman, so that's basically what I was referring to, right? So this model, okay, the pre-trained V2 model, that is actually what you fine tune, has two components in it, right? So the G is basically generative. It's a generative model, and D is discriminative, right? So what they do is the generative model tries to generate an audio saying, hey, this is the audio I think is the right audio, and the discriminator looks at the audio and says, hey, yes, this is good or it's bad. Right, so D is only used to fine tune a model, but when it comes to inferring, or when you're actually once your model training is done, D is useless. You can throw it away. You just need G path, right? So D is only for training. G is the one which is actually the one which you end up using in your model. Are phonemes matching always one to one, or there's possibility of one to many? Great question. Yes, it can be one to many. It can be many to one. That can also result in mispronunciations. Um, because, like I said, right. So there's some hacks that you can put in there to figure out what should be an ideal phoneme there. But at this point, it is a basic distance matching, right? Even if you look at FIRES, it is simply computing the distance between incoming phoneme to all the existing phonemes that are seen in the training data, and it'll just simply pick it's a greedy search. It'll pick the best one, and the best one may or may not be the right one, right? So the best one might probably be below it. So we can probably come up with a little smarter way of doing it, the bunch of them, in terms of like using the previous context and next context and all those things. But yes, it is possible to fix that. How much data do I need? I think that we answered. Can Taiwanese AI voice be used? Of course you can. But like I said, the base model is in English. So as long all the phonemes in Taiwanese language, which is part of English, or which kind of overlaps with English, I think it'll work out of the box. Only those phonemes that are not part of English it'll sound accent. You'll probably it'll probably not pronounce it at all, or it'll probably sound very Americanized. Right. So, but if you can simply use, like I was saying, right. So, pick up a model, Hubert model, which is multilingual. So, wave to wake or whisper models, and then for the second one, right, the pre-trained V2 model, that's something you probably need to fine tune with Taiwanese. Let's say we want to, anonymous question, we want to have the best possible conversion quality in a non-English language with the existing ROC version. What we should do in an ideal scenario? Should we start fine-tuning with multiple hours of dataset that contains multiple voices? No. So okay. So wait 1 second. You want, why do you don't need, wait, did it?
No, he's talking about those phoneme mismatches when you're saying that Hubert and all that,
Okay.
that English thing, right? If they want to get that multilinguality thing kind of
No, I don't think
baked
he's
in.
talking about multilingual. He's talking about within. He's clearly saying, "I want." Oh no, sorry, non-English
No,
language.
non-English. It says non-English. It says
Okay,
non-English. Okay. Yeah.
non-English language. Yeah. So start with fine-tuning with multiple hours of data that contains multiple voices. Hey, yeah. So we probably need to train. Okay, so I'll tell you this, right? So you probably cannot. Again, this is my hunch. You can give it a shot, right? But the pre-train the code in RVC that is given to you is a fine-tuning code, which means the parameters that that are chosen for training are solely for fine-tuning, right? So I'm not sure when I say fine-tuning, it may not have the best of the learning rates to get to your end, or say get to your best model very quickly. So it is tuned in such a way, or rather the parameters are chosen in such a way that when you have a limited amount of data, quickly learning with a limited amount of data by not changing too much of the model, right? So that is how the current parameters are given to you. If you are training it on multiple hours of data with multiple voices in different languages, then ideally you should be looking at the original training code, not the fine-tuning code. And the training code is something that you probably need to build from scratch, but you can simply leverage what is available in the WITS paper that I shared before, right? So that already gives you the training code. You can simply take that, train the model, the same GND model that we're talking about before, and then use that for multilingual version. Can you share some keyword to use when you used that? Can you share some keyword for audio lip sync? I don't know if I covered that.
I'm not sure I understand the question correctly.
Yeah, I'll probably come back to that later. Okay, if Tran, if you're around, can you probably rephrase that and
yeah.
I'll go to the anonymous one. How to create a model that is truly multilingual? Does it take? I think does it make sense to generate with 11 labs TPS multiple?
Oh wait,
Well,
who's this? Who's this? I really want to know who you are, man. I mean, the anonymous.
well, that's actually a great idea. I should go ahead and try it. I think that'll help. But you'll like I was saying before, right? You need to come up with the training code for it, the training pipeline for it. You can probably start. There are base codes available for the WITS training, WITS model training. Start with that. But for the data, great idea for getting the data. How many convolutional layers RVC has? Hey, okay, I can show you the code. I don't have the exact answer for that, Alex. But if you want, it's pretty straightforward, right? So in the sense, okay, I'll probably answer that I'll give you the code. You can go check it out. Wait, where is the?
I remember printing a lot of these models, and my terminal output was like totally jammed. Like back very early days when I was playing with this.
Is it possible to attach an RVC model as an ANN layer in transformer? That's basically what I was talking about. That it is possible. I mean, theoretically, it is possible. It is simple. After all, mapping phoneme embeddings to audio. So you could simply the first qubit model where you're going from audio to phoneme embeddings. You can replace that with a model that can go from text to phoneme embeddings, and I think you're good to go. I think it should work out of the box. That's for the last anonymous question.
Yeah.
All right. I think we're done. We answered most of them.
Perfect. Yeah, I'll just quickly clear the questions.
Oh, there are more. Huh? I saw something. Are you using the extract of similar? Okay, that's for tonight to answer.
We might open source what we did. So yeah, maybe stick around for a bit while. I mean, for a longer while. I mean, definitely not on this call, but maybe in a couple of weeks we might open source what we have built. So yeah.
All right. Cool. Thanks, guys. This was interesting. Yeah.
Okay, so I'll quickly give because we gave you a small sort of a class, if I may, or a session or some sort of a lecture. I think it totally makes sense that we give you some homework, and I am particularly impressed by that anonymous guy. Maybe ping me separately on the Discord, because that was the first one. Can we take the small sample of voice and use 11 labs and create a balanced data set? So yeah, again, as Dr. Sharad said, you're absolutely right. You can definitely play around with it. But again, yeah, creating that balance, you will have to be a bit more creative. So what I did personally was I used these Azure and Azure emotive voices, wherein they have these what I forgot what is it called, the SSML tags in the speakers, wherein they are deliberately saying, yeah, this will speak in an angry voice, this will speak in a sleepy voice, so on and so forth. So whispering and all are covered there a bit in a bit better way. So instead of relying on 11 labs, maybe you could try it on a lower version and then see how it goes out. The second idea that the second rad homework idea that I have is can we look at a train model and decide if it's balanced or not? Because right now, as I see, even Blaze and all of these guys, they have created this huge repository, huge collection, huge API of all of these models wherein you can query. There are a lot of Google Sheets that has all the AI models, everything. But again, it's we have very less clarity on if a model is usable or not. Because personally, what has happened, I think, and I use the Kanye one because I think that's the most downloaded RVC model out there. But I think except the first three models, all the other Kanye models are not very good. So when I say good, I mean speaker similarity and speaker intelligibility. Similarity is nothing but a fancy way of saying, does this output sound like Kanye or not? And intelligibility is nothing but whenever it is saying something or whenever it's generating an output, can I understand it? Is it flat? Is it pronunciation? Is it pronouncing everything correctly or not? So that is that. The hint to this assignment is I personally wrote a blog. It's called Evals Are All You Need, and that's definitely on our black.dubverse.ai website. Do check it out. I also made a shitty, I won't say shitty, I would say a V0.00001 level PR in that original RVC repo by RVC boss. So yeah, definitely do check out the code. Do see how this pans out. And yeah, can we make a tool that looks at the training data and score it in certain parameters? So I think this is an open question, and I think I'd like to leave you all of you guys with the same question that what's the point, right? Because if we are trying to create all of these RVC models, how do we make sure that they come out good or not? Because again, at the end of the day, I'll repeat what I started with and I kept on repeating throughout the call is it's a very simple pipeline. It's dividing it into chunks. And all you need to make sure to get a good model a good trained model is that you have to make sure it has seen all of those chunks before. So can we maybe this could be picked up as an engineering project in AI Hub or any other place. If you have any questions or if you want to run anything through us, you can definitely ping us on Discord. We are there. And of course, most of you are on our Discord as well. And yeah, V2 of RVC text-to-speech is nothing but, as Dr. Sharad said, that we make sure that we can extend it into multiple languages. So yeah, these I'll leave you guys with these small 4 homework assignments. If anyone has something interesting, do share it with me or any of the admins that you guys work with in your respective Discords. So I'll quickly go ahead and see. I think Tran hasn't replied back yet. Dr. Sharad, if you could come again, we'll just close all the remaining questions. And now what I'll do is I'll open stage for all of you. If you guys learned anything new or if you want to discuss anything, the stage is yours. Just raise a hand and then I'll invite you in as a speaker. So yeah, first time I think 24 people. I think we started with around 20 and I see a lot of people came in, joined and all. I think net around 30 to 35 unique new people kind of joined our webinar. And I'm happy to see that even with a lot of these technical jargons and other things that we were speaking, still there are 24 people who stuck around till the end.
Yeah.
So yeah, guys, the stage is yours. If you want to, we are almost at the wrap up time. So if you want to, speak about anything, if you want to understand anything, or if you want to share anything that you learned new today, or maybe you would want to learn in the next session, if we decide to do it, you can maybe put it as a question, or maybe you could come out and say it. Yeah, I think that's probably it. Train function that we optimize for. Okay, we have Joseph. Joseph, I'll quickly let you in. Let participate. Yeah. You should be able to come in now. Hi, Joseph. You can unmute and then you can maybe tell us what you wanted to talk about. If you're trying to say something, you're on mute.
Oh, I can unmute.
Oh, you cannot unmute?
So that's weird. Okay.
I don't know. Interesting. I mean, yeah. You already have, I think, all of these. I'll add as co-presenter. I'll add as a co-host. Maybe try now if you can unmute. Not sure what's happening. Anyone else who wants to speak? Maybe you could put it as a question again, whatever you want to talk about. Alex wants to speak. Okay, Alex, letting you in. Let participate. Yeah. Alex, I'd also like to know what is it that you do. I mean, you sound like a proper R&D AI guy, right? What's your day job, man? What's your day job like? Before we go into
are you asking me?
Yes, I'm asking you.
Well, I'm a programmer in like a very professional company, but I'm very interested in AI, so I really like to contribute.
Interesting. So what is it that you wanted to talk about?
Well, basically, the main problem with RVC currently is first technical issue is that, well, model architecture is very convoluted, like unnecessarily convoluted.
I agree.
And the code itself is extremely spaghetti-like. It's impossible to navigate in it.
I think it's in Japanese or Chinese, right? When I was trying to understand what it was doing, I mean, I literally put a lot of print statements at all the places I could find, and I think a lot of these print statements still kept to that PR that I made. So yeah, I completely with you on that one.
Yeah, and the main issue is that, well, sometimes instead of using multi-dimensional convoluted model, they just make a workaround and make multiple single-dimensional convoluted models for no reason. And this is literally the main issue with RVC, because in the end, the model weights, G and D weights specifically, they come out extremely huge. And I was wondering if you guys had been able to fix that stuff.
Well,
I'll kind of take this. Yeah, I'm not working. I mean, so I'm working on that easy UI fork of the RVC thing. So I cleaned up all of the code that I wanted to. I got rid of all of these random things that I thought they kind of didn't make sense for my use case. So I'm working. I mean, whenever I train my models, I train it on a separate instance that's separate from the current branches of all of these other ones. I think I'm on easy 10/9/10 or something. I'll drop it with the tech and other things. The one that I'm using.
But Alex, if that's interesting for you, right? It probably will. Okay, probably I'll put it in this way. Right? So why we kind of thought we'll have this one-on-one was because it was a challenge for us to understand what is happening here. We spent some time doing it. We thought it'll probably make sense for us to kind of talk about it as well. And that's why this happened. This webinar happened. If you still believe that, I mean, I'm completely aligned with you saying when you say that, hey, there's the code is really convoluted and probably we can do it in a much simpler way. I strongly believe, yes, it can be done that way. And if that's something that you have the bandwidth, then we can probably work closely on that and then make sure that we have a cleaner version available for as an open source code that people can play around with. I mean, that can be one of our homework ideas that Tanya was talking about. It frankly doesn't take too much effort, right? We know exactly what they're doing, and some of these models are open source and available already. So just need to stitch together in a nice, clean manner and train it.
Yeah. Also, I would like to suggest not using the EasyGUI fork, simply because the code there is not optimal, to say at least. And
I mean, it's also written by students, so it's okay. I mean, I can't expect the quality from them. I'm happy that they've shared it online, and then there's some thing to start off with, but we can take it up and clean it up.
Yeah, I mean, that's what I did. I picked up it and cleaned it up, and awesome. Optimized training and inference stuff. So I can send you the repo if you want.
Yeah, please. Maybe drop it in the questions and answers tab. I mean, I'm not sure if you can still send messages. If you can send.
But Alex, are you part of the Discord group as well? Then you can probably have it here, right?
Yeah.
Okay. And we can start.
Okay, man. I've seen you around on. I've seen a lot of your repositories here and there. I didn't know you're Alex Markov. Hello, big fan.
Hey. Thank you. In fact,
I have it.
I'm very happy that people actually spend their time to work on RVC itself, including the Applio devs, you guys. Like, there's a lot of people who actually are passionate about this stuff, and that makes me happy. I just want this community to grow and improve on its own, basically. So I support you.
Awesome.
Thank you, Alex.
We should do this together more often.
Yeah.
I agree.
Send me a ping. I'll make you a community admin on our Discord. Next, then you're hosting the next one.
Yeah, because we can probably spend time going through the things that you worked on. This the repo that you just shared. That can be a. I mean, we want to learn. Probably it'll be easier to learn via you, where you kind of walk us through the code, and then it'll be easier that way.
Oh, and also, sure, but like, there's a thing that someone else wanted to say. basically, those are not my words, but someone said that one of your ideas of using 11 labs is flawed, because if you are wanting consistent data set augmentation, 11 labs would not be a good choice, as it already struggles with more nuanced voices and accents, as well as staying consistent.
No, so wait, what I meant there was, okay, so probably it was misunderstood, but what I was trying to say was, if you want the RVC voice, the trained RVC voice to be expressive enough, you probably need to go collect expressive audio recordings yourself, right? So, which means, I mean, it probably is easy. Like, for instance, if you want to get Kanye may not be, but for instance, okay, I'll probably put it in a different way. If your RVC model that you just trained needs to talk in an emotional manner, like a very angry voice and very sad voice, it can't do it if you're not trained it with that kind of a data. You need that kind of a data. As practitioners who probably don't have enough resources, we probably won't have the money to go get a voice actor and record those kind of extreme voices for us, or extreme emotional voices for us. We probably end up, at least the way we looked at it was saying, hey, is it a model issue or is it the data issue? Right? Do I need to change my model to kind of start supporting these kind of emotions, or can I simply use the same model, give the right data to it, and will it already start supporting it? And to test that hypothesis, you can simply use any of these existing teachers. I'm not saying for production quality, right? I'm saying, hey, go get your 11 labs voice for those emotional content, because the current RVC model is not trained on emotional content. It's only trained on read monotonous speech, right? Read speech. When someone is reading a book, they probably don't emote so much. So when you want to test the RVC model and test the limits of how much emotional it can speak, this is the kind that you need to train it with emotional data, or data with those vocal modulations. That is something, if you can't probably afford to go get a voice actor to record it in a certain quality, because recording data to train a TTS model itself is a pain. So hence, it'll probably, to quickly, to fasten your, experimentation, it's simpler to use any of these 11 labs, or even I think Microsoft Azure also has, for some of their neural voices, they have also different kind of data. Yeah. That's something that you can leverage as well, right? So that was the only point I was trying to convey there. Probably it was I probably misread it, but this is what I was trying to convey.
About the emotion stuff, I completely agree, because people on AI Hub, what they usually do is they make multiple versions of their models, like aggressive, emotional, just monotone, sad, etc. But I don't really think that this is the problem of. Hold on a second. Excuse me. Yeah, here. So I don't really think that this is the problem of a model. Actually, this is the problem. This is not the problem of data. I just think that, in the first place, it should have been implemented with emotional support. And
no, wait. So that's probably you're right. But probably the angle that I'm thinking of is in the scenario that you were training data that you use to fine-tune your RVC model has some emotions, where the same phoneme is roughly is seen in different kind of pitch ranges, right? So, like for instance, one of the non-linguistic feature that we use, non-linguistic as in feature that is not related to the text, is pitch, right? So if like I was talking, I think for the V2 model, I think the second input it takes is pitch. I agree, probably pitch by itself may not be good enough for copying emotions, all kinds of emotions. But in terms of the modulations that I would probably see in a TTS voice from 11 Labs or TTS voice, emotional TTS voice from Azure, probably this pitch will work out of the box. But I hear you, and I probably agree with you when you say, hey, for the extreme, for all the kind of timbre, that the kind of voice texture that you would want and all that, probably there having a more fine-tuned feature would help, right? So that's probably where all the TTS models nowadays are using, because there was a prosody embedding or a GST and things like that, right? So that's probably the second. So in the input in this current slide that I'm showing right now, there are two versions of this GND model. One of the one of them also takes phoneme embeddings and pitch, two inputs. So that pitch is where probably it will help for this. Is one of the non-linguistic features that helps in kind of controlling the. So, for instance, if there are two phonemes with different pitch points, it'll probably choose the right phoneme with the right pitch. So that's basically the intuition, high-level intuition. But I kind of agree that pitch alone may not be enough for solving the entire problem, entire prosody problem.
Yeah, so why I've been talking about pitch is not about pitch, or about emotions, is because I've come up with an idea of basically making like submodel that will basically detect emotions in the data set and match them with the emotions on the inferred data. So basically, it will match the emotions and produce, therefore, an emotional like output of the audio. And the solution this is practically the best, and people will be able to manually specify what section of the audio will be in what emotion. They will be able to fine-tune the model, but it will also be able to auto-detect emotions and stuff. That I just think that this is a very neat idea.
Is it? Have you put it somewhere? Is it part of the GitHub repo that we can kind of, or is it something that we can get into detail after probably the next time? I'm curious to understand what you're doing, basically.
It's kind of private right now, and whenever it will be in a release state, I'll be able to show it. Yeah.
All right, sure. Looking forward to that.
Also, there's a lot of things in RVC that people have wanted for years and like never got them.
Yeah.
For example, the Voris conversion, using Voris and RVC, basically, it's a thing that basically it just changes the whole game of our ritual-based voice conversions. And it was promised to be in a V3, but instead we're just getting a lot of pre-trains. So that might be another idea for you guys, just to consider it.
Got it. Makes sense.
Exciting,
Alex. We have a lot of cool things that you're working on.
Yeah.
Yeah. Yeah.
Also, one thing that is also quite interesting to think about is the Hertz limitation. Because currently in RVC, we have a thing.
They go on, Alex.
Basically, in RVC, we have a Hertz limitation to the input audio that is inferenced. And this thing, like it's kind of fairly new. Like I added it just to see if it would work, and results are very cool. However, the issue is that it applies to the whole audio, and you cannot select where you would want where would you want it to differ. So you cannot lower or raise the ceiling of the Hertz limitation if you need it to lower or raise. So having a very simple, how's it called?
It's the sampling rate. You're talking about the sampling rate, right? You're saying that the 16 kilohertz limitation that it has is probably not the best. You wanted it to be much higher than that. That you solved it in some way, but when you want it to be less than 16 kilohertz, which is, I don't know, let's say 8 or something like that, is something that you're not solved, is what you say. Is that right? Did I understand it right?
No, I'm more saying of make the way to change the Hertz limitation dynamically. So whenever you want the screaming data, you'll be able to lower it, and whenever you want more precise and detailed data, you will just raise it again.
Got it. But you want to do it at this model level? I mean, because why can't that be a post-processing step? I'm just, oh no, they wanted streaming. But if you wanted streaming, then okay, it won't. I mean, it's difficult, right? Because the second the pre-trained V2 model, I mean, in my understanding, is not an auto-regressive one. It takes the entire sequence and gives an entire sequence out. So you can't really stream that in real time. Or am I not getting it right?
I mean, basically the extraction is a side. It's just a side thing that happens whenever the training is occurring. So it extracts the pitch and then it pops it into the model.
Correct.
So it will be able to dynamically change it. theoretically, of course. But to be honest, I don't see any problems. I don't really know what would even the problem be. Just you can change it dynamically. Just pass it in the function that extracts the pitch and data.
True, but you could change it dynamically, but then the range of pitch it could support is it's kind of limited to the range of pitch it is seeing in your training data, right? So it is something. I mean, it may or it may not work probably because of the data is what I'm thinking. Probably. Right. So I mean, I hear you. What you're basically saying is, hey, we're extracting the pitch and giving that as an input to the second model, the pre-trained V2 model. So I can actually dynamically change the pitch to the range that I want. Probably yes, it should work, but as long as the range is what your V2 model has seen before. If it has not seen that before, it probably wouldn't do a good job at it. It can probably extrapolate a little bit, but when it goes to too extreme, it may not do a good job. That's my thought.
This will mostly affect RMVP because of the way it is built and its structure. So this will not be actually very beneficial for a lot of extraction algorithms like CREP. Like you wouldn't be able to see any difference in it. But for RMVP specifically, this will be, well, very noticeable whenever you change the pitch.
Interesting.
Pitch range, basically, yeah.
Got it. Interesting. I've not faced that, so I'm not sure.
Well, yeah, guys. If at any point, basically, you need any help, like don't hesitate to ask anyone. That's
why.
By all
100%.
Thanks, Alex. Joseph, you had a question.
Yes, thank you. Thank you. My microphone is working now. Okay, so first of all, thank you very much for your time, and I really appreciate that you explained this. Thank you. Thank you very much. So I wanted to follow up on two subjects. One is multiple voices. Use multiple voices while training. So I will just maybe share what I tried, what are my observation, and just to confirm with you, maybe I have false conclusion. So what I did is I use let's say as example half hour per voice, and I have, let's say I don't know 10 voices. 10 like real voices, and we are talking about a high fidelity audio, no garbage. It's really studio high quality audio. So we have a 10 persons, half hour per person. This is 5 hours, right? So I do fine tuning with this data set, maybe for a couple hundreds epochs, and then I stop and I finish this with only one voice. So what happened when I compare, if I train directly only with one voice from this, let's say, English DNG paths, I can see that if I do this extra work, the result is more flexible. I can put as an input the different samples, and output is like more flexible. I can have more emotions, more like styles of pronunciation, or it gives me more flexible results. But maybe it's I don't know, maybe it's a false conclusion, but this is just my observation, and I don't know. What do you think about this?
That's interesting. So what you've done is you only trained, and this data that you're talking about is in English? No, it's in different languages.
Oh, no English. Different languages. I test with different languages.
So 10 speakers, all of them in different languages?
It's one. So let's say, as example, let's say Spanish. I have a Spanish, or I have a Greek, or right, I have
10 speakers, all Spanish, half an hour each.
Yes.
Totally 5 hours. You fine tune with it, and then
Yes.
towards the end of the fine tuning, you refine-tuned it on just one of the speakers.
Yes.
And this 10 hours of data that you had across this, 5 hours of data you had across the speakers, was it monotonous, or was it actually a lot of voice modulation where the person was emotional and all those things? And did it contain that kind of data as well?
Well, maybe some are like
Or
monotonous.
let's talk about the final one, the one which you finally, the single speaker that you fine-tuned towards the end. Did that have emotional content? No, because you said it's flexible, so I'm curious what kind of data that was towards the end.
Yes. Okay. So I tested both. I have samples with monotonous, just reading, and I also have recordings with a lot of emotions. So I tested like both, and of course I have a much more flexibility. It's like kind of more smart. This model, RVC model, if it also includes more emotions. Yeah, so that's true. That's affect the quality. That's true. But I mean, if this like extra in the middle, like you inject this extra step, with multiple speakers, if does it make sense or no?
It probably makes sense, because I think that was something I was talking about. So I mean, did you also try this experiment where without that intermediate step, the middle step where you're training with 10 speakers, if you just train it on the same one speaker, would the quality be different? Is it do you still get the same quality? So
yes. So yes. Of course I tested to train directly without this extra effort, and in most languages, if my data set for that one speaker is long enough, then yes, I do not have any more English bias. So that's fine. But really, it must be more than half hour, maybe 45 minutes, maybe 1 hour, and then it's like 100% that vernacular language, the target language that I want to create model for. Right?
Are you still using Hubert? Because what you're fine-tuning is just the pre-trained V2 model, and if you're saying that although you trained it on 45 minutes, you're saying that when you trained it on 45 minutes of Spanish data, and you've not touched the Hubert model, you still you're actually getting great quality pronunciation in Spanish.
Yes.
Interesting. Okay, because I was of a different opinion there, but then so the Hubert model is able to capture some of the Spanish phonemes, most of the Spanish phonemes in a good way then.
Yes, actually, I have amazing results with non-English languages. Like I have a feedback like amazing quality, perfect. It sounds like native speaker, and I tested in
languages. I mean, it's possible, right? So, like I was saying, most of the phonemes across languages are similar, especially the Latin languages. So, if you're just transferring from English to some other Latin languages, it's very similar, right? So, probably the few phonemes. I'm just thinking, are there phonemes in Spanish that are different than English?
Let me chat GPT.
Yes, for example, there is a S sound. This is very common, because in Spanish many times you have it like th.
Okay, and it gets the right.
Yeah, and actually, yes, of course, we have like a perfect 100% Spanish. It's very nice. So, and you see, this is like related with the second subject, multi-language training, because really, if I try some English models to do conversion, for example, in my language, there is only one problem with R sound. R. Everything else is fine, because probably there is a huge overlap between those two languages. So because English does not have a R sound, yes, of course, it sounds always a R. Like English speaker. Okay, so if I train with my language, then I overcome. But for example, if I create Spanish, Spanish nice high quality model, I am happy for Spanish conversion, and I try, for example, Greek or Italian audio to convert. Then, for example, I have problem with S. It's not like bad. It sounds like Spanish. It's nice, but only maybe S or another letter. So then here is the idea, like, okay, why not do with 11 Labs, to generate text to speech? I select, for example, Michael voice, and I generate Spanish, half hour of Spanish, and then with the same voice I generate Italian and Greek and Turkish, and I generate half hour of every language. But because it's the same voice, and I will train with this data set, it will like understand it will understand and become like more smart and be able to convert those languages. But I don't know, is this conclusion false or
no, it is true, but you probably also need to change the Hubert model, right? So in the sense that where was this model that you had? Go to that bigger problem, this one, right? So here, right? So what you're saying is, in this particular slide, all your fine-tuning that you're doing across languages and across voices, across the number of speakers, is just the Kanye RVC. But that may not be sufficient, because at the end of the day, Hubert is also important, where Hubert is the one which is able to differentiate between two phonemes. Right. So right now, why you're getting mispronunciations for some of these phonemes is Hubert is failing at recognizing those unique phonemes of different languages. That's where I'm saying, hey, the way you're training, I think this was a good input for us as well, where you're saying, hey, I can simply fine-tune the RVC model that I have on multiple speakers, and then towards the end fine-tune it to the specific speaker that I want. That is giving me a much better quality. Great. But some of those unique phonemes, I think, will not. What's the pronunciation of that will not solve until you probably replace the Hubert model with something else, right? So that something else needs to be a multilingual model. Most of these more recent, or say SSL models with the way2vec, the XLSR version and all that, you can simply pick those embeddings and start using it. Because since these models have been trained on hundreds of languages, so the units or the embeddings that they generate can better differentiate the phonemes that are across languages. So that's the gap. So if it can better differentiate the phonemes across the languages, it is able to better index it when we're talking about this example, right? Where we have for every phoneme we need a corresponding mapping in other language. All right. So this, basically when we index it in FIAS, when we index these phonemes in this FIAS block, it's able to clearly differentiate which phoneme to use, and all those things.
Yes, makes sense. And please, because I do not have experience with this Hubert based model and to create my own version. So can you please share some link or give me some tip if, let's say, I want to create my own base model that would be
you can start with something that's available open source, right? So there are bigger models. So there are multilingual models already available that you can simply pick up and replace the Hubert with. You can start with that, and if it's not giving the quality that you want, then you can think of fine-tuning it yourself. That's my suggestion. But you can, if it excites you to train it yourself, go for it.
Okay, thank you very much. And maybe a last question about this index, because I am so sorry, maybe I did not understood correctly. So we need to index those features or those units, so then we can do this inference. But this index data are saved in this index file, right?
Yes.
So I
don't know how exactly. What is the file name? Probably Tanay, you might be a better person to answer that. I'm not sure what file name it is saving it in RVC code.
Okay.
I don't remember it right now, but I can probably let them share. Yeah.
All right. Because we have we always by training we create those two files, right? PTH file and index file. It starts with edit when we train a feature index, right? So this index file, yes, we can use it when we do inference, but when I don't use it, it's fine. It still works. So how it can work if it does not have this index data?
I've probably. That's a good question. I have not tried it myself.
I've experienced something similar, but I never investigated why this is happening.
Yeah, and for example, if I do fusion, right, I can fuse multiple models. There is no index file. Of course, I can like randomly select one of the index file from those models that I used for fusion. Yes, I don't know if that makes sense, but there is no really no index file for fused model. And it works like, and of course, sometimes I just forget to select index file from the drop-down menu. So I do inference, and yeah, it sounds good, and I am happy with the outcome. And then I see, oh, I forgot to select index file. So well, do I need it? I don't understand this.
It is okay. Wait. So I remember something. Okay, so one hypothesis, right? So again, because none of these models, this probably, I think that's a good point that you raised. I'm just connecting the dots and here, where they don't download the Hubert model directly from the Hugging Face Hubert, Hubert repo, right? So they download it from their own repo. So which possibly means they've done something to this model. And in one of the models that in one of the papers that they have, they also mention, it's not related to this, but the same people who are part of RVC have in one of the papers that kind of updated the Hubert model to remove the user information from it, right? So they, like for instance, the phonetic embeddings that you're getting here, where I'm calling it, hey, there's a Kanye's embedding and there's Steve's embedding. It need not be, right? I mean, if you think of it as a character, if you're going from audio to characters, if let's say Kanye is saying RVC training and inference, the output should just be RVC training and inference. It cannot be RVC. You cannot have different RVC training and inference text based on the speaker, right? So you're completely removing the speaker information and getting only the actual units, right? So that is something that they had done in one of their papers. Now connecting the dots where you're saying, hey, this, even if I remove the index, so the index file, the FIAS is critical if they've not done the speaker, if they've not removed the speaker information from the Hubert embeddings. Right. So in that scenario, I can simply use the Steve phoneme embeddings and give it to the Kanye RVC. It should work out of the box because the phoneme embeddings doesn't have speaker information in it already. Right. You've removed it completely. It is just a sequence of characters in some embedding space. In that scenario, FIAS is not required. FIAS is only required when the embedding sequence of has some mismatch in terms of the distribution. Right. So Steve has a different kind of a distribution for phonemes, and Kanye has a different distribution of phonemes, and that is what you're trying to match using FIAS. But if you remove the speaker identity in these embeddings, it probably, then you don't really need that index file. Index file is just a proxy then at that point. Now, if you're saying that without the index file, it gives me exactly the same result, and with the index file, then it kind of says, I mean, it's good that you tried it. I don't think I had tried it before. So which means that it's probably, that's the case, right? Where they're using a Hubert model which doesn't embed the speaker information. That's what I'm thinking. Alex, do you have any thoughts? You raised your hand. Do you have some thoughts on that?
I'll have to invite him back. Wait.
Oh, all right. Okay. But Joseph, did it make sense, or did I confuse?
Yes, it makes sense. Yes. Thank you. I appreciate this.
Alex, yeah, sorry, you had some.
Yeah, well, not really. I don't have thoughts on this, but like the most obvious solution I have for this exact issue with not having an index for the fused models is basically take the two indexes and just randomly mix them together. That is very simple to do. That's very simple to do, but I'm not sure about how good results would be. That's just a thought.
No, but for me, the interesting point which Joseph mentioned was, even if you delete the index file, it works perfectly fine.
Yeah, like
so
I'm pretty sure it will do something.
But maybe the difference is that many times I use a search feature ratio as a 0. Maybe if I use it like 0.5 or 1, maybe then I will see, okay, it's not working, there is some problem. But many times I use it at the 0 level, because then it respects the emotion, the melody, prosody, everything of a sample input audio. So this is what I want. But yeah, I did not test a lot if I use a search feature ratio, some value higher than 0.
Well, basically what index is used for, like mostly, is the accent stuff. It should not actually affect any melody part of the input audio. And well, mostly it just it affects the accent of the input audio. So it just tries to match it to the accent that was the model was trained on.
Yeah. Okay. Thank you. Thank you.
You're welcome. Also, some people are concerned about licensing you'll do with your project. So are you planning to keep the project open source and free, or are you going to quote unquote sell it?
No, I think this piece, I mean, we're doing this as open source effort completely because this was exciting for us and we just picked it up, and then everything is there, right? There's nothing that I can kind of make money out of here, right? So we're just kind of making it open source. So that we thought we want to build this community, and then we thought there's a great place to start.
That's good to hear. That's good to hear.
Yeah. Any of the AI Hub engineers here would want to come on the stage and maybe say a couple of words? I see a couple of names that I think I might know, but definitely I don't want to call anyone out here. So anyone of these engineers would want to maybe come on stage? Yeah, I think, or maybe you could call it a wrap. It's like midnight here in India. So both for me and Dr. Sharad, and I think both of us have had a pretty long day because we are doing this kind of, separate from our kind of day jobs here. No one?
I think people are just afraid of lots of other people.
I mean, yeah, it's good. It's good. Not any shut up.
That's an open thing, right? No one is. Everyone is just talking about their experience, so it's fine.
Yeah.
No one has all the answers.
Correct. Okay, cool. Thank you everyone for joining us. I think I'm happy that even after overrunning this by almost like 40 minutes, we still have 25 people who are listening to the random thing that we've been blabbering about. So thank you so much for joining us. What I'll do is this session was definitely recorded. I actually have my day job at Dubverse, wherein I'm one of the founding team members there. What Dubverse does basically is convert videos into multiple languages. So what I'll do is I'll put the recording and then give you multiple give you the same webinar in other languages as well. So yeah,
that's good to hear. So
I share this as a playlist, like people who weren't able to join in, and for even if anyone wants to go back to the webinar and refer to certain pieces, yeah, you can do that.
That's good to hear. Thank you guys for this webinar.
Thank you so much, guys. Have a great day, everyone. Bye-bye.
Thank you.